Suppose we have two events, A and B. Remember, the set A intersect B will include the elements that are in both sets, since in this context, an element is one of the possible outcomes of one trial of a random experiment, and an event occurs if one of its component outcomes is the actual result, and an element of A intersect B is in A and also in B, then the event A intersect B occurs only when both A and B occur simultaneously. We call A intersect B a conjunction, and it's convenient to describe this as a both A and B event. Another useful phrasing is A and also B. For example, suppose a 20-sided die is rolled. Let E be the event that an even number is rolled, and Q the event that the number rolled is a perfect square. The event E intersect Q will occur when the number rolled is both an even number and also a perfect square. And so we can just list the elements, the possible outcomes that are both even and also perfect squares, and those would be: in a perfect world, anytime we're interested in a conjunction, we'll use phrasings like events A and B occur simultaneously, both A and B occur, A and also B occur. We don't live in that world. For example, maybe we have a set of objects. Some are square, some are made of wood. So again, while we are focusing on the event, it's worth considering what the experiment could have been. In this case, maybe there's a bunch of objects in a bag and we select one. And note that our sample space is the object we selected. So maybe it's a wooden triangle, a plastic spoon, a solid gold dancer, whatever. And we could have events like Q, they are square, and W, made of wood, and even more if we wanted. So a wooden square is something that is both a square, that's in Q, and also made of wood, W, so it's an element of Q intersect W. Meanwhile, a plastic square is both a square Q and not made of wood, that's W complement, so it's an element of Q intersect W complement. And so the important thing to notice here is that we have events that are conjunctions that correspond to the intersection of two events, but the way that they're expressed does not use the both and phrasing. So we have a lot of hidden conjunctions when we talk about events, and it's important to be aware of them. Suppose we have two events A and B. Remember, A union B includes all elements either in A or in B. So suppose the event A union B occurs. Since, in this context, an element is one of the possible outcomes of one trial of a random experiment, an event occurs if one of its component outcomes is the actual result, the elements of A union B are either in A or in B, then the event A union B is the same as the event either A occurred or B occurred. And this is called a disjunction. For example, suppose D is the event a person goes out to dinner and M is the event a person goes to the movies. Then the event D union M is the event that either a person goes to dinner or goes to the movies. Now, mathematicians use an inclusive OR. If a person went to dinner and also went to the movies, the event D union M still occurred. This distinction is important because in natural languages we often default to the exclusive OR. You can have cake or you can have ice cream, and it's implied that you can't have both. However, unless it's specified, you should assume we are using the mathematical, the inclusive OR. If it's not written down, it didn't happen. So disjunctions can be written without using the either or phrasing. Usually we at least use or, but sometimes we don't. For example, At a wedding party, the guests were served steak and chicken. Even though we use the word and, this is probably not a conjunction. The assumption here is guests aren't served both steak and also chicken, at least not at any weddings I've been invited to. It's probably intended that guests are served steak or chicken, so as a statement, this is a disjunction.